Hello guys and welcome back to my channel Interview with Bunny, and today we will start with the third video of our system designing playlist. And the topic that we will be discussing today is a very critical and a hot topic for any system designing interview, and that is designing a e-commerce platform. So here you can easily take an example of an e-commerce giant like Amazon, Flipkart or any similar application that allow user to purchase goods online. So that is the discussion topic for today. So without wasting much time, let's start with designing an e-commerce giant like Amazon.com. So as I've already told you in my last two videos, system designing is a very vague topic. Means your interviewer will simply ask you a question like design an e-commerce platform like Amazon, and it is your responsibility to collect all the functional and non-functional requirements, and you have to proceed with your designing. So let's start with the first step of our system designing, and that is the gathering of the functional and the non-functional requirement for our system. So as you are already familiar with an e-commerce platform like Amazon, so requirement gathering over here will be very much easy. But the problem over here is, since Amazon is a huge application, you have to clearly specify which aspect of your application you should design. Means whether you have to design the user flow or you have to design the backend flow, means the warehouse, maintaining and inventory. So you have to be 100% clear with what your interviewer is asking during your technical interview. So in today's video, we will try to cover most of the concept for an e-commerce platform. So let's start with the first step of our system designing, and that is the requirement gathering. So the first primary requirement would be the user should be able to log into our application and search any product in our application with the help of some search criteria. That should be the first requirement. The second requirement is, once the user gets the matching item based on his requirement, the user should be able to see the detail of the product. Means what is the specification of the product, who is the manufacturer, what is the review and all those stuff. And once he get all the information, the next step is he should select a quantity and add the product into the cart. And as you know, once the item is in the cart, the next step is he should be able to make the payment successfully and check out his cart. So these are primarily the four most important requirements on the user flow. But apart from this, there are a few more functional requirements that you have to also consider while designing this system. That is, user should be able to track the status of his order. And last, whenever there is a product that is on the limited quantity, you have to design the system in such a way that the concurrent purchase of any product is handled efficiently. So these are the 5 to 6 system designing requirements that we will be discussing and designing in depth in this system designing interview. So let's first write down all the functional requirements over here. So here if you look carefully, these are all the functional requirements for our system. That is, user should be able to search and find a product based on the product title or name. Number 2, user should be able to view the details of the product, that is description, image, quantity that is available, review of the product and all these things. Number 3, user should be able to select the quantity and move the item into the cart. Number 4, user should be able to make the payment and do the checkout successfully. Number 5, user should be able to check the status of the order. And number 6, we have to efficiently manage the purchase of any item that is in the limited stock. For example, there is a flash sale on the iPhone that is going on in our application, and thousands of customers trying to book only 5 to 6 available iPhone from our inventory. So we have to design our system in such a way that that race condition is handled efficiently. So these are primarily all the 6 functional requirements for our system. Now, since we have understood and discussed with your interviewer that what are the functional requirements that we are targeting, let's now move to the non-functional aspect of this requirement. And as I have told you before, non-functional requirement means the characteristics of the system, means how the system should behave. So let's list down all the non-functional requirements for this system. So the first non-functional requirement that you should ask your interviewer is, what is the scale of the system that we are targeting? Because knowing the scale of the system is very much important to take some of the critical decisions during our interview. So let's first estimate the scale of this system. So the scale that we are targeting in this system designing 10 million monthly active user, and we are targeting 10 orders per second, means our order service should be highly efficient enough to accept 10 orders per second. So that is the scale of the system that we are targeting. So as you can see here, we are discussing a lot of traffic and lot of volume of data that we have to handle. Now let's discuss about the next most critical important thing of a non-functional requirement, and that is the cap theorem. So as I've already told you in our last video, cap theorem tells that whenever you are trying to create a distributed system, it is not possible to achieve high availability and high consistency on a particular module. And as you can see clearly from the scale of this system, here by default we have to go with the microservice architecture, because this is a huge amount of traffic and no server can single-handedly manage this amount of load on the system. And since we are going with the microservice approach or with the concept of the distributed system, so obviously we have to prioritize between the consistency and the availability of the system. And here if you look carefully, our system needs both of them, means we need consistency as well as availability. So let's discuss in detail that which part of our application should be highly available and which part of our application should be highly consistent. So if you just look into the requirement, you can easily analyze that there are a lot of daily active users who are actually searching products in our application. So our searching module should be highly available. Otherwise, if our searching logic doesn't work all the time, no user can be able to search any product, and thus it will be a very bad experience for the user. Thus our search module should be highly available. But with respect to consistency, our system should be highly consistent on two modules. Number one, the payment and the order management, and number two, the inventory management. So do not worry, we will discuss in detail that how we will achieve all these non-functional characteristics in our system. So just to give you a heads up, this video might be a bit longer than the usual, because designing an e-commerce platform is a very critical task, and here I will try to cover each and every small concept as much as possible, so that with the help of that concept you can design any similar or any relevant topic during your system designing. So let's first write down the non-functional requirement of the cap theorem that we have discussed right now. So this is our non-functional requirement, and one more non-functional requirement that you have to see, and that is the latency of the system. Means whenever a user is trying to search a product, at that time the response should come up as soon as possible. And as I've told you in my previous video also, whenever you are discussing the latency or any of the non-functional requirement, do not forget to quantify it. So over here also we are targeting the latency of around 200 milliseconds. So as you can see here, we have listed down all the functional and the non-functional requirement of our system. Now let's start with the second step of our system designing, and that is the identification of the core entity. So here if you understand the requirement, you can easily identify few of the core entities that are possible. So the first core entity that we can easily identify is number one, the user, number two, the product, number three, the cart, number four, the orders, and number five, that is the checkout. So these are primarily the five major core entities that we can identify as of now. It might can happen that there are few more other entities that we can identify in the future, but as of now, these are the most important five core entity for our system. So let's write down all those five core entities over here. Now the next step of the system designing that you have to do is the API creation. And as you know, listing down the REST endpoint are very simple if you have already gathered the functional requirement properly, because in most of the case it is just a one-to-one mapping that a single functional requirement can be served by a single or a couple of REST endpoints. So here let us first list down all the major API endpoints that we can identify. So the first endpoint that we have to design is this one. That is, we have to provision our system in such a way so that users should be able to search and find products based on the product title or name. So the first endpoint that we will expose over here is a search endpoint. And as you know, since we are searching products from our database, so obviously it will be a GET endpoint. So let's see what will be the signature of this GET endpoint. So our search REST endpoint would look something like this. So here you can see this is our API path, and this is the search term, maybe the keywords keywords or the name of the product by which a user should be able to search a particular item. So what will be the response for this endpoint? That is the list of all the matching products based on the search term. So here what we'll do, we will provide a list of all the matching products. And here we will return all the product IDs. So this might be a product ID or some partial data of the product. Maybe you can just send some metadata of the product like the thumbnail of the image, the price and all these things means a partial list of information you can send in response. So this should be a partial information. And one thing you should remember, whenever you are designing a search, there can be thousands of records that can come in your search result. And in your response, if you try to send all those thousands and thousands of responses or the result to the front end, your front end will hang or it will be damn slow and the latency of the system will increase significantly. So to reduce the latency of our search API, what we have to do, we have to send the result in the form of the pagination. So here do not forget to mention to your interviewer that the result will be coming in the form of the pagination. So this becomes our first REST endpoint. Now the next REST endpoint that we have to design, that is the user should be able to view the details of the product. So the next endpoint will also become a GET call because we are getting the information from our database. So here also this will be a GET call and the signature of this endpoint should look something like this. So here you can see we have the product endpoints where we are just passing the product ID that we are getting from our previous result. And the return type of this endpoint will be the metadata of the product, that is the product details. And it should be in the form of a JSON. I hope this is clear. Now let's see what will be the next endpoint. And the next endpoint that we have to create is to support the third requirement, and that is user should be able to select the quantity and move the item to the cart. And here if you understand it correctly, since we are inserting our data into our database, so it will be a post call. So let's see what will be the signature over here. So this is how the endpoint will look like. So here we are trying to add an item into the cart, and since this is a post call, so in our request body we have to send the product ID that we want to add into the cart, and in the header we have to pass the user ID so that we can able to match that which user is adding which item to his cart. And the return type of this request will be the cart ID. So along with this, there can be few more APIs that we have to create. Means, for example, you want to update some item from the cart and you want to delete an item from the cart. So all those endpoints you can easily add in your requirement designing. But my suggestion would be, since you do not have that much time during your system designing, skip those steps and just inform the interviewer verbally that these are the additional APIs that you should also maintain in your system. Now let's see what will be the next API endpoint that we have to design to fulfill our requirement, and that is the checkout and the payment process. So if you understand it correctly, checkout is a two-step process. Means whenever we are doing a checkout, first we have to do a checkout, and once the checkout is done successfully, we will be landed into a payment gateway, and there we have to make the payment to complete the ordering process successfully. So here we have to list down both the API endpoint, that is for the checkout and the payment gateway. So this is how your payment and the checkout API will look like. So here you can see we have the checkout API, where in the body of the checkout API, we are passing all the product IDs, the quantity and the price, and in return the checkout API will return an order ID for that particular request. And based on that order ID, we have to make a payment request where we have to give the order ID that we have received from here, as well as all the metadata of the payment, means the card detail, the expiration date, the CVV. And based on this post body, a request will go to our payment gateway, and from there we will get an acknowledgement, that is whether it is a confirmation or a failure. And based on that confirmation, we will mark our order as successfully placed or failed. So these are more or less the 4 API endpoints that we require for ordering a particular item in our application. Now the last but not the least, we have to make a provision for the user to check the status of the order. So it will be a simple GET call where the user can see the status of the order. So let's list down the last and the final endpoint over here. And that's it. I hope we have covered almost all the major endpoints that we need to design this system with respect to the functional requirement that we have gathered. So there can be a number of other APIs that will be required to design the system. But believe me, during your system designing round, you do not have to write down all those API endpoints. Otherwise, it will take up a lot of your time and you won't be able to design the actual thing, and that is the high level and the low level designing of the system. So here you can see we have already completed the three major important steps of your system designing, that is gathering of the requirements, identification of the core entities, and the API designing. Now let's move to the most important thing, and that is the high level designing of this e-commerce platform. And believe me, as I tell you in every video, high level designing is very easy if you have managed to progress until this point. So let's start with the high level designing of our e-commerce platform. So the flow of this system is quite simple. That is, we have thousands of users across the world who are trying to interact with our system, and our system in the backend is trying to interact with the DB to fetch all the details of the product and place the order successfully. So that is basically the high level concept of the system. So let's design one component at a time. After that, we will deep dive into each and every component and we will see in detail that how each and every component will interact with itself and how we will manage all the orderings, bookings, and everything concurrently. So let's start with the high level designing. So here the first thing is the user who are trying to interact with our application, and since here you can see we are talking about a huge scale of the system. So obviously, as I have already told you, this amount of scale is not possible to handle by a single server, and that is why we have to go with the microservice architecture, where we have to create separate services which will be responsible for performing a particular function. So to talk to those microservices, we need an API gateway and a load balancer to handle that much amount of traffic. So over here what we'll do, we will create a load balancer and an API gateway. And the simple algorithm and the logic the load balancer will be following is the round robin algorithm. And here the main responsibility of the API gateway will be number one, routing of the traffic to the respective server. Number two, authentication and authorization of the user. And number three, the rate limiting. So let's list down all those things here. So this will be the core responsibility of our API gateway. Now let's see what will be the services that we have to deploy in our backend. So since you have understand it clearly that we are going with the microservice architecture, so here if you read the functional requirement carefully, you can easily identify that what are the core services that we have to create. So the first service that we have to create is a search service by which user will be able to search the products based on some keywords. Number two, a product service by which the metadata of the product have to get ingested in our system. Now the next microservice that you have to create is the cart service, means by which user will be able to add item into the cart. And number four, we have to design a checkout service by which user will be do a successful checkout. Number five, the payment service by which user have to make the payment. And number six, the order status service by which user should see all the status of the orders that he or she have already placed. So here you can see, here we are talking about a lot of microservices that we have to design to implement or fulfill all these functional requirements. So let's list down all the microservices in a very high level that we need to design our system. So here you can see these are majorly all the services that we require to design our system. And one more thing I forgot to mention, and that is we need an additional service, that is a user service, because obviously when a user lands to our application, he have to first do a login and a sign up, right? Because otherwise we won't be knowing that which address we have to send the delivery, what is the contact details, and all the metadata that we need to place a particular order. So here you can see these are all the list of services. Now let's see in a high level how this component will interact with each other to fulfill all the functional requirement that we have listed over here. So the first and the foremost thing is like we need a database to store the metadata of each and every product that are available in our system. So here we will create a database called as product database. Now, what will be the type of the database and what are the attributes that we will store over here? I will not go into that detail in the high level designing. Here we will simply identify that we need a database to store all the information, because all those detailed discussion we will be doing in our low level designing, where we will see in detail that what are the attributes that we have to save, how we have to save, and what will be the perfect database to fulfill all the condition. But over here, since this is a high level design, we will simply point out that we need a database to save the information of the product. I think this is clear. And how the system will interact? Here from our API gateway, we will call our product service, and this product service will directly interact with our product DB to update each and every metadata of the product. Now what we'll do? We have to implement the search service. And what will happen in the search service? That is, whenever a user is trying to search a particular item, obviously the request will first come to our API gateway, and based on the URL that is provided, our API gateway will route the traffic to our search service. And what the search service will do? Our search service will write a query over this product DB to find out all the relevant information that matches the search criteria. Now let's assume that our search service managed to find out all the relevant product based on the search criteria. Now what the user will do? User have to add that item into his cart, and for that he will again make one more request to our API gateway, and our API gateway will route the traffic to our cart service. And here our cart service have to store the information of that cart to a particular database. So here also we need another database called as cart DB. Now the next flow is like, once the item is in the cart, he have to do the checkout, and for that what we have to do? We have to call the checkout service, and this checkout service will internally called another service, and that is the payment service. So here we have to list down another service, and that is the payment service. And this payment service will again internally call another service, that is the payment gateway. That will be completely a third-party application that we do not have to consider. But here we will simply identify it that this payment service will call another service, and that is our payment gateway service. I hope you are understanding the flow, that how stepwise we are trying to build this system. And believe me, if you go in a very logical way, it will be very easy for you to design any large scale application. Now let's see what can be the other thing. So here if you see, once the payment is successful and we are done with the checkout process, we have to obviously save that information for future use, because there is a requirement that user should be able to see all the status of his order. And to get the status of each and every order, we have to maintain a database where we have to store all those information. So here we have to create another database called as checkout or a order database. So all the order related information will go into our order database, means whether it is a failed or a successful order. Similarly, our payment service also have to store all the information of the payment, so that in the future we can easily see whether a particular payment was a successful or it was a failed transaction. So here also we have to create one more database, that is the payment database. Now the last important service that we have to point out over here is the order status service, which will be useful to retrieve all the order history or all the status of the order. And from where we can get the status of the order? We can get the status from here. So our API will hit our order service, and our order service will check our order DB, and from here it will give the response that whether the order was successful or what is the status of the order. Now the final and the last flow that is remaining over here is the user flow. So whenever a user land to our application, he have to first do a sign up, and for that we have to save all the user related metadata into a separate database, and that will be a user database. So here if you see, we have tried to convert all the functional requirement into a pictorial logical view, where we have created separate microservices for performing each and every activity. And here you can see each and every microservice is talking to a particular DB to perform a particular role. And if you just go through each and every requirement over here, you can see this high level designing easily fulfill all your requirement. That is, for example, the user should be able to search and find product. So here you can see once the user lands over here, he have to first do a sign up, and all the sign up related information will go to our user DB. And once he is a registered user, he can easily search a product into our database, for which we have our search service, which will query our product database to find out all the relevant information. And once the user gets the particular product, he have to add the item into the cart with the help of the cart service. and once it is added to the cart service, he have to proceed with the checkout. For that we have the checkout service, which will internally call the payment service, and once the payment is successful, the information regarding the payment will be saved into the database, and the status of that order will be saved into our database. And once the order has been successfully placed or it is failed, we can easily check the status of that order with this order status service. So here you can see we have successfully designed entire high level architecture of our system, which is fulfilling more or less all the functional requirements that we have gathered at the very beginning. But believe me, listing down this is not enough, because this is quite a high level designing and you might not clear your interview if you just design this much, because there are a lot of concepts that you have to go in detail and you have to tell and explain to your interviewer that how this search service will work in your product database, how you're maintaining the concurrency, and there are a lot of things that we have to learn over here. So let's go into the next important thing, and that is the low level designing of this system, where we will see each and every component that we have listed over here, and we will check in detail that how we should scale this system, what will be the characteristic of the system, how we should partition, or what will be the database that we have to choose, how we should scale our database. And there are a lot of concepts that we have to discuss in our low level designing. So believe me, in our low level designing, we will learn a lot of things. I mean a lot of things. So without wasting much time, let's go to the next and the final step of this system designing video, and that is a low level designing of this e-commerce platform. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So far you have seen that how incrementally we are improving our high level designing to fulfill all the functional requirement of our system. Now let's move into the deep dive analysis of each and every component, and we will fulfill all the non-functional requirement of the system like consistency, availability, and we will try to improve all those characters of the system. So let's start with the low level and in-depth designing of each and every component that we have specified right now. So the first thing that I will do, I will copy the entire high level designing from here, and let's start with the low level design. So here we will start with one component at a time. So let's first see how this user service will work. So here, as you know, once the user come to our application, the first thing that the user have to do is to log in or sign up into our application. And since the data that we are saving in the system is quite simple and it have to be consistent, so what we'll do here, the database that we will choose to save all the metadata of the customer is a MySQL database. So what I will do here, I will simply mention it that the database that we will be using over here is MySQL database. Now let's see what are the attributes that we need to store to identify a particular user. So the metadata that we need to save for a particular user is a name, email ID, password, and some list of addresses where he want to deliver his products. So here at the side of the DB, I will mention the schema structure of this database. So this will be a user DB and it will have this following columns. So these are some key metadata that we have to store in our user database. So this is a very simple flow. So what happens is like whenever the user sign up for the first time, he save all this metadata into our DB, and in future when he try to log into our application, we validate the credential with the user ID and password that is saved in the user database, and if the user is validated, we share the JWT token from here, and the JWT token that we will share after the authorization, that token will be used to call all these further services, and that authentication will be done by the load balancer or the API gateway that we have put at the very beginning. So I hope this is clear that how the data are flowing within the system. Now let's go to the next service, and that is a very important service, and that is the search service. So if you look carefully in the non-functional requirement that we have gathered, here it is telling that the latency of the search should be within 200 milliseconds, and this search should be highly available. So here you can see we have to do something to optimize this searching algorithm. So let's first understand that what can be the problem with this design. So here if you look carefully, there are thousands and thousands of products that we are saving within our database. And if a user want to search for a particular item based on the keyword or the title of that item, then what we have to do, we have to scan this entire DB, and from that DB we have to list down all the products that match the criteria. So here you can easily understand that for each and every search request, we have to scan this entire database from top to bottom, and from there we have to give the relevant information to the user. So this is highly a time consuming activity, and this is not at all optimized. So let's see what can be the solution to optimize this searching algorithm. So the first approach by which we can optimize this search engine is by optimizing this database. So for example, here we are using a MySQL database. Then what we can do, we can simply put a indexing on the title. But even though we put a indexing on the title, searching this entire database will be very time consuming. So by anyhow, we cannot go with this approach. So what can be the other approaches? So the other solution will be the same solution by which we have solved our ticket booking system that we have discussed in our last video. That is using the Elasticsearch. So let's see how we will do the Elasticsearch and how we will optimize this search engine. So the first thing what we have to do, instead of scanning this entire database, we have to introduce an external system that is called as Elasticsearch. So here we have the Elasticsearch. So here right now the search service will not interact with the database, rather it will interact with the Elasticsearch algorithm, and this solution will be damn efficient because Elasticsearch is highly efficient on any type of searching, whether it is a text-based searching or any type of searching you want. So introducing a Elasticsearch over here will be a great approach to solve this problem. Now let's see what can be the other possible problem that can happen after introducing the Elasticsearch over here. So the main problem that will happen over here, and I think you have already identified, that is how the Elasticsearch engine will get the real-time data from this product DB, because this product DB will have all the information of the product, starting from the availability of the product, the quantity of the product. So somehow we have to feed this entire database or the entire data of this database into our Elasticsearch engine. And normally what we do for that, we use the CDC pipeline. And I hope you already know what is the CDC pipeline and how do we implement that. Because in our last video, I have told you in detail that what is a CDC and how should we implement a CDC pipeline to ingest the data from a particular database to the Elasticsearch. So I would highly recommend you, if you have not gone through my previous video, go and check that video first and then come back to this video. But I will just give you an overview that how CDC works. That is, whenever there is a change in this database, there will be a connector service that will capture all the delta or the changed event that happened within this database, and those data will get pushed to any streaming platform, that is a Kafka or something, and from that Kafka, the data will get propagated to the Elasticsearch. So whatever the changes that are happening in the real time within this product DB, all those changes will get captured by the Kafka, and from there it will get migrated to the Elasticsearch. So here what we will do to synchronize this database with the Elasticsearch, we will implement the CDC pipeline over here. I think this is clear. Now let's see what will be the schema structure of this product database and which DB we should use over here to store all the metadata of the product. So the database that we will choose over here is a document DB or a MongoDB, because here we have to save a lot of information of the product in the form of the document or a JSON. So the best database to save all the metadata of the product is a MongoDB or a document DB, because MongoDB is very much flexible to the schema structure and it is quite optimized for searching. So because here if you understand, all the products on the Amazon might not have the same product details. The product details might vary from product to product, and to maintain that flexible schema structure, Here we are using the document DB or the MongoDB to serve our purpose. So let's now see what will be the schema structure. So if you understand it correctly, each and every product should have a product ID, the name of the product, the description, the category, the quantity that is available in the warehouse, price of the product, and the currency. So these are few of the metadata that should be there for each and every product in the database. So let's list down all the metadatas here. So I hope you are clear with that what are the metadata that we are saving for each and every product. Now let's see one more thing, that is whenever a product is getting uploaded into our database, there are few things that get uploaded. One is the metadata of the product and also the image of the product, because whenever you are visiting an e-commerce platform, very obviously we need the image of the product to see what we are ordering. So somehow here also we have to store the images of each and every product. And to store the images in a very efficient manner, what we will do, we will use a blob storage here. So the first approach can be, we can simply upload a blob image into our database, but obviously uploading those many of the images of high resolution will be a very much data consuming job, because for example, each of the images is for 2 MB, and for example, if you have millions of images, you can easily estimate that what is the amount of data we are simply storing in a database, which is not at all recommended. So for that, to store the images separately, we will be using a separate blob storage or some S3 bucket over here. So what we will do, we will simply introduce a S3 bucket here to store all the images. And how we will map these images in the product database? That is, here in the metadata part, we have to list down all the blob URLs of the images. So for example, for a particular product, there can be 7 to 8 images, and all those image URL from the blob will be stored here as a simple text. And whenever the user is making a search of the product, what happens is, like in the backend, this metadata will get passed from the Elasticsearch, and here in the search service, the search service will actually make a call to this S3 bucket, and it will get the actual images from here and it will pass it to the downstream. Or a better approach can be, since these images are some static images, so here instead of storing in this S3 bucket, we can also store the replica set of these images in a CDN library over here, so that all these images will be very much near to the user, and once the user try to search for a particular product, we will simply send this URL to the front end, and from the front end we will make a call to the CDN library to get the actual images from here, because this approach will be super quick and your front end will be highly optimized to render the UI page. So this can be the two approaches by which we have to store the data in our database. So the first approach is, we have to store the data in the MongoDB or any document DB. Next, all the images should be stored in the S3 bucket, and this S3 bucket should get replicated to the CDN library, so that whenever a user is searching for a product, we will simply pass the CDN URL to the front end, and from the front end we will simply call the CDN library to render all the images for the user. That will be super quick and very efficient way to handle this amount of data. So I hope we got the idea how the product service, search service, and the user service will work. But believe me, there is still one thing that we have to optimize. That is, we have mentioned the quantity over here as the metadata of the product, but saving the quantity of the inventory within this MongoDB or within this database is not an optimal solution. But as of now, let's keep it like this, and let's move to the next service, and that is the cart service. So the cart service, or the way we will be implementing the cart service, is quite simple. That is, whenever the user is choosing a product, he simply have to choose the number of quantity and simply have to save the item in the cart. So that will be a very straightforward flow. But let's see how we should save the data in the cart. So the way we should save the data in the cart is quite simple. That is, over here, since we need a consistent system, that's why we will choose a simple Postgres database to save all the information about the cart. And let's see what can be the schema structure of the cart database. So the schema structure of the cart database will be very simple. That is, we will be having a cart ID, a user ID, and the list of the products that he want to add in the cart. So let's first define the schema over here. So this is how the schema of the cart DB will look like. So here we will be having a cart ID, the user ID, and the list of the product a user have added into the cart. And here in the list of the products, we will be having the product ID and the quantity. So for example, you want to purchase a single iPhone. So here it will be the product ID of the iPhone and the quantity should be 1. But look carefully, we are not saving the price over here because obviously the price of the iPhone will vary from time to time. So it will not happen that you have added in a cart for 1 lakh and after 10 days it might get reduced or it might increase. So on each and every time whenever you are refreshing the cart or you want to view the cart service have to internally call this product database to check the updated value of the iPhone or the updated value of this product. And based on that updated value, it have to render all the prices and it have to send the updated valuation of the cart to the user. So that will be the simple flow of our cart service. I hope still now we are on track of how we are incrementally adding the functionality of each and every service to fulfill all the functional as well as non-functional requirement. Now let's move to the next service and probably the most critical of all of them, and that is the checkout service. So before going to the order status service, we would like to see how this checkout service will work, because here we have to explore a lot of new things by which we will be doing this designing. So let's first explore that how we should implement this checkout service, and post that we will check this order status service. So let's start with designing the checkout service over here. So the way the checkout service works is like, so for example, you have a cart in the UI and you want to place an order for that cart. So what will happen? The entire cart will come to our checkout service, and once the payment is made successfully, we can simply say that the transaction was successful and you have placed the order successfully. But before proceeding to the payment gateway, there is a critical and a very important thing that you have to do. That is, before placing the order, we have to check the inventory, that whether the quantity that the user is opting for, whether that amount of quantity is present in our inventory or not. So for example, yesterday I have added 3 iPhone in my cart. Now on the next day when I am placing the order, it might can happen that those number of iPhone are not present in the inventory. So before the cart move to the checkout process, we have to check the inventory, that whether that amount of item or the quantity of the item that you are looking for, whether that sufficient amount of item is present in the inventory or not. And to check that, what we have to do, we have to introduce a separate services that is called as an inventory service. So let's now introduce a new service called an inventory service, and after that we will see how we will solve the concurrency problem and how we will manage the inventory of this giant e-commerce platform. So over here what I will do, I will introduce another service called as inventory service. And the primary role of this inventory service is to check whether the opted number of quantity of a particular item is present in the inventory or not. And to check all the available quantity of the particular product, we have to have an inventory database in our system, which will have all the products and the corresponding available quantity for each and every product in our inventory. So over here what we'll do, we will have an inventory database to track all the products and the quantity of the inventory. And believe me, this database should be highly consistent, because by anyhow, if the consistency of this database is violated, there will be a serious problem. So for example, a user have purchased the product and he have made all the payments and everything, but the product itself is not present in the inventory. So obviously that will be a very bad experience for the user and also for the reputation of the Amazon. So this inventory database should be highly consistent, so that on each and every transaction, whatever is happening on Amazon, the quantity should get reflected or should get updated every single time. And this database should be the only source of truth of total number of quantity that are present in our inventory. So believe me, this database is the backbone of our core inventory system. And to achieve the consistency and availability of this database, what we have to do, we have to choose this database carefully. And the database that we will be choosing over here will be a Postgres database, where the indexing will be on the product ID. So here what I will do, I will mention all those details by the side of this inventory database. So here you can see this will be our inventory database, which is a Postgres database, which is indexed on the product ID, and it should be the only source of truth for the total number of quantities of product available in the inventory. And our inventory service will be solely responsible to update any changes on this inventory database. Now let's see, before placing a particular order, what will be the data flow. So here, once the user places an order to his cart, means the cart ID along with all the products that are in the cart will come to this checkout service. Now internally, what checkout service will do, this checkout service will internally call this inventory service to check whether all the quantities that the user is opting for each and every product, whether that is available in our inventory or not. And if it is available, then only it will proceed to the payment service. And if it is not available in the inventory, here only before making the payment, we will notify the user that the number of quantity that he is asking for is right now not available. So let me mention that flow properly over here. So here, before placing the order or before proceeding to the payment service, here our cart service will do this validation. That is, it will check the stock availability before checkout. And once it get a green signal from the inventory service, then only it will proceed for the payment. So the next step will be make the payment. And thus the user will land to our payment service where he have to enter all the payment related credentials like the card details and everything, and combining all those metadata of the product as well as the card detail, we will make a third party call to our payment gateway service to confirm the booking. And once the payment is done successfully, what we have to do? We have to simply update our payment database over here, which is a very straightforward process. But even the payment fails, we have to still update that entry within this database, because all the payment related transaction, all the status should be present within this payment DB. Along with only updating the payment DB, we have to also do a couple of things. That is, once the payment is successful, we have to also update our order database so that in the future the user can see what is the status of his order. As well as we have to update our inventory system, means since there is one product that got purchased, so we have to decrease a quantity from our inventory. So here we have to make another call from this payment service to our inventory service. So ideally this should not be done by the payment service, it should be done by the checkout service, but I am simply showing it so that you easily understand the flow. So the first thing what we have to do, we have to update the payment DB. Number 2, we have to update the inventory system. And number 3, once everything is successful, we have to update the order database with the status of the order. So here if you look carefully, this payment service or the checkout service is actually doing a lot of concurrent work together. And since this is a part of the single transaction, there can be a very critical problem that can happen. So for example, the payment has been done successfully, but the service might not able to update the inventory system. Or it might happen that you have purchased the product, but the third activity, that is the updating the order database, failed. So here if you understand it clearly, there is a very critical problem of maintaining the consistency and idempotency for this system, because we cannot guarantee that all these 3 steps will be done after the payment is done successfully. So this approach is not a good or an optimized solution to solve this kind of problem. So let's now see what can be the best solution so that we can create a consistent ordering system or the checkout system over here. So what we will do to make this system consistent, we will replace all these 3 API calls with a single event. Here, instead of payment service making all these 3 calls separately for a particular transaction, here we will introduce a Kafka service to handle all these things. So let me show you how we will do it. So the first thing that we'll do, once the payment has been done successfully, this payment service will simply update the payment database over here. So this functionality is fine, but we will remove these 2 other steps, that is updating the inventory service and updating this order service. So what we'll do, we'll get rid of these 2 steps. And here in this system, we will introduce a Kafka broker. So let me introduce a Kafka, and after that I will explain you the entire flow, what we are actually designing and how it will work. So what happens is like once the payment service confirms the payment, whether it's a failed or a successful payment, once the checkout service receive an acknowledgement from the payment service, it will simply throw an event to the Kafka broker with the status of the payment. Means it will have enter object of the card as well as the status of the payment. So all those attributes will get posted in this Kafka broker. Now once this event get generated in the Kafka broker, what we have to do? We have to write some consumer service to update each and every database. So here from the Kafka broker, we will have two consumers. One consumer service to update the status of the order and another consumer to update the inventory system. So here we will first write the flow. So here we have two consumer. One is the order consumer, which will read the order topic from this Kafka. And once this order topic is updated with the latest order of the status of the order, it will simply connect to this consumer using the Kafka connect, and it will consume the data and it will simply update this order database. And thus it will be a very near real-time scenario of updating the database as soon as your payment is successful. Similarly, over here also, our inventory service will check the inventory topic, and whenever there is a change on that topic, it will simply consume that event and it will simply update our inventory database using this inventory system that we have over here. And thus with these approaches, you can see the rate of failure or idempotency or the consistency of these entire services changes drastically. Because right now, since Kafka is highly available, so we can be 100% sure that whatever the event that took place within this payment service will get posted in the Kafka topic, and eventually this two consumer service, that is the order service and the inventory service, will consume that data and will update the corresponding database. So I hope you are clear with how this checkout flow is working. I think this is clear, but still there is something that you have to consider over here. That is, once the order is placed successfully or our order is failed, we have to send notification to the user about the status of the order. And for that, what we have to do, here we have to introduce one more service, that is a notification service, which will also read from this Kafka and it will notify all the user regarding the status of the checkout that just happened right now. So here we will introduce a notification service. So I hope you are clear with the entire checkout flow, means how the cart is going to the checkout process, how we are validating with the inventory system about the quantity, and once there is sufficient quantity in the inventory, we are proceeding further for the payment. And once the payment is confirmed, then what we are doing, we are updating the payment database and we are sending an acknowledgement to the checkout service. And thereafter, once the checkout service receive an acknowledgement, it will send an event to our Kafka broker, and from that Kafka broker, all the downstream application, that is the order database, the inventory manager and the notification service, will consume the data and it will perform its own work to update the order DB, the inventory DB, and send the notification to all the user. So this is actually the entire flow how the checkout system will work. Now let's see what will be the choice of the database for this order DB. So here, since the order DB should be highly consistent, so here we will simply go with a MySQL database. And the schema structure will have the order ID, the user ID, the list of the item, the price of the basket, and the payment ID, and so on. So let me first list down the schema structure for this order database. So here you can see this is the product database and this will be the schema structure, that is the order ID, the user ID, the items that he have purchases. So here it will be having the product ID, the quantity, the price at the time when he have purchased, the currency, the total valuation of the cart, the payment ID, and the status. So this will be the schema structure for this order database. So you can see we have almost completed everything that we have gathered in our system designing requirement. But if you look carefully, there is one more requirement that we have to still fulfill, that is managing the purchase of the item having limited stock. So this point is still not achieved, because if you look carefully, there is still a flow by which this requirement can be validated. So let's first understand the flow, why we need to introduce that check. So here, since we are using a microservice architecture, so obviously all the services will have the replica set, or it will be scaled based on the requirement. So for example, this checkout service have 10 replica set, because here if you look carefully, this checkout have to handle 10 orders per second, and to support that amount of threshold, we have to obviously scale this checkout service properly. So let's take example. We are having 10 instances of this checkout service, and right now a sale is going on live at Amazon, and there is a single iPhone that is present in our warehouse, and maybe thousands of the user are trying to purchase that single iPhone at a particular time. So what will happen is like, so for example, 10 customer is trying to purchase the same iPhone over here, and let's assume that all those 10 requests have landed to all the 10 different checkout services that we have over here. And once the user is placing the order, what will happen? It will check the inventory service, and it will take that one instance of iPhone is still left. Similarly, the second instance of the checkout service will also look into this inventory database, and it will see that still one instance of the iPhone is present. And in this way, since all the events are happening concurrently, so all the 10 checkout service will call the inventory service, and all the response will be same, that is a single instance of iPhone is still available. And thus what will happen, since the checkout service will see that the number of quantity the user is purchasing is present in the inventory, so it will proceed further with the payment service, and thus the payment will happen successfully, but we do not have 10 iPhone in our inventory, and thus that will be a very bad user experience. So what we have to do here, we have to handle that REST scenario explicitly. So let's see how we will do it. So over here, to handle this type of REST scenario, we take the help of the Redis log. So what we will do here, we will introduce a Redis log. So what happened is like, whenever a particular user is trying to purchase an iPhone, we will first check that whether the iPhone is present in the inventory or not. And if it is present in the inventory, what we will do, we will simply acquire a log on that iPhone with that amount of quantity. So since here we are purchasing a single iPhone, so our log will be on the product ID, user ID, and the total number of quantity of iPhone the user want to purchase. So that will be the log that we will acquire in this Redis cluster. And along with that, we should also mention a TTL for that log. So it might happen that the user do not purchase that item, so our log should get expired after a few seconds. So what we'll do here, we will be explicitly putting a log, and we will set the TTL for 30 seconds or 1 minute. That is the maximum time it might take for the checkout process. And you can see with these approaches, once the log is there for a particular product, we can ensure that the REST condition will get handled efficiently, because at the same time when the second user is trying to purchase the same iPhone, at that time though we will get from the inventory service that there is still one iPhone available, but we will see that there is a log that is explicitly mentioned on that iPhone, and thus the checkout process will fail over here, and we can send a notification to the user that there are not enough items that are present in our inventory. And thus with this approach, we can easily fulfill the sixth and the last functional requirement, that is purchasing of the order having the limited stock. So I hope you have thoroughly understood the scenario and how we are explicitly applying log on each and every product that are very limited in the stock. And that's it. We are almost done designing all the services that we have mentioned over here. The last but not the least is the order status service, which is very much straightforward. That is, once the user try to check the status of the order, it will simply call this order database, and from there it will simply try to find out the order ID, and it will give the status to the user. That is a very straightforward scenario. But there are few more additional things that you have to implement to make your system highly resilient and consistent. Let me show you what are those. So over here, if you look carefully, this inventory database is the core of our application. Means if this inventory database goes down, there is no way we can check that what is the total number of quantity of the product available in our warehouse. So here we have to handle this scenario carefully. So here if you see, whatever the order that gets placed in our system, that is 10 requests per second, all of those requests are calling our inventory service, and thus you can simply assume that what is the total number of hit we are getting in this DB. That is too high because we are assuming we are having 10 requests per second, and since this structure is a backbone to our system, there is a single point of failure in this inventory database. So here we have to optimize it again further so that we do not go into that route where our database fails. So what we will do to optimize this route furthermore, we will simply introduce a caching layer in front of this inventory database. So what we will do, let me clear it out a bit. Here we will introduce Redis cluster in front of this inventory database so that the inventory service, instead of calling the inventory DB each and every time, it first check the Redis cluster that what is the total number of quantity of the product that is available. Thus, with this approach, we can simply reduce the total number of calls to this database. But if you look carefully, with the introduction of this Redis cluster over here, there can be a problem with the consistency. So for example, there is a single instance of iPhone in our DB, and thus once the inventory service calls this DB, it will get cached into our Redis cluster. Now once the order has been placed, this inventory manager service which we have created over here will try to reduce the quantity of the iPhone by 1. So right now the inventory service have the quantity as 0 and the Redis cluster have the quantity of iPhone as 1, which violates the principle of consistency. So to solve that, what we have to do, we have to write a very efficient caching policy to handle the consistency of the system. So here also what we can do to solve this problem, we can go with two approaches. One, we can go with the write-through caching mechanism. Means whenever there is an update in the database, this inventory service will update both the cache as well as in the DB. Or what we can do, we can implement a CDC pipeline again over here to update all the quantities of the item in near real time. So this can be the two approaches by which we can invalidate the data in the cache to achieve the consistency of the system. I hope this is clear. Now let's go to the last and the final thing, and that is here if you look carefully in the product database, here we have an attribute called as quantity, which is actually required to show the user that what is the quantity of the item that are still left in our inventory. But here if you see, whatever the transaction that is going over here, this quantity that is present in the MongoDB is not getting affected by anyhow. Means though the item is getting purchased from our inventory, but this quantity is still not getting updated. So here we have to write a mechanism to update the quantity of the product in real time. And the best way to solve that problem is put a simple cron job or a Kafka pipeline or a CDC pipeline to update the quantity in near real time. So what we'll do here, there will be another call that will go to the product database to update the quantity of the item. So this will again become a CDC pipeline which will update the quantity of each and every item that is getting purchased or returned in our inventory. And thus, if you look carefully, right now our entire design is more or less ready for production. And if you look carefully, here we have designed our system keeping in mind all the functional and the non-functional requirement that we have gathered at the very starting of our interview. So I hope you have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you on our next video where we will be solving another problem on system designing. So see you on our next video. Thank you.